Hello everyone, I welcome you to ICS Mahesh PU College Dharwad YouTube channel, Department of Chemistry. Students, we are discussing the topic the solid state. In our previous class, we had discussed about calculation of number of particles in the unit cell. We have discussed in the beginning the contribution of lattice points in the unit cell based on the number of neighboring unit cells. Firstly, lattice point at the corner is shared with 8 nearby unit cell. Therefore, its contribution is 1 by 8. Number 2, body centered lattice point. It is shared with only one unit cell. Hence, its contribution is 1 whole particle. Third, lattice point at the face center. It is shared with 2 nearby unit cells. Therefore, its contribution is half, that is 1 by 2. Fourth, lattice point at the edge. It is shared with 4 unit cells and hence its contribution is 1 by 4. By using this, we have calculated number of particles in simple cube, body centered cube, face centered cube, etc. The calculation in simple cube is 8 into 1 by 8 is equal to 1. Number of particle in simple cube is 1. Face centered cube, calculation is 8 into 1 by 8 plus 6 into 1 by 2, which is 1 plus 3, that is 4. 4 is the particle. Number 3, body center, 8 into 1 by 8 plus 1 into 1, that is 2. End center, 8 into 1 by 8 plus 2 into 1 by 2, that is 1 plus 1, that is 2. Edge center, 8 into 1 by 8 plus 12 into 1 by 4, that is 1 plus 3, 4. We have calculated this in our previous slide. Dear student, we have to apply this knowledge to solve numericals. So, we have to practice numericals, dear student. In today's class, we are going to understand about numericals on the calculation of number of particles. We are going to find out the formula, and in the later part of the discussion, we are going to understand about the three-dimensional structure of the solid. Let us understand the numericals first. Let us understand the numericals on number of atoms on the unit cell. First problem. Look at this. 2 marks. They are going to ask this question. Remember, students, reading question is a very important task. You have to read the question thoroughly. Okay, you know the concept, apply the concept and get the answer. Let us read the question. A cubic solid is made of 2 elements P and Q. Atoms of Q are at the corners of the cube and atoms of P are at the body center. What is the formula of the compound? This is asked. No need to draw the diagram, but to have an imagination is important. Okay, I have used this diagram, dear students, to explain this numerical. See, this is a cube and hence a cubic solid S made out of two particle. S, it is made out of two particle, one is P and Q. Okay, atoms of Q are at the corner. See, these corner lattice points are named as Q and P at the body center. See, this lattice point is P, which is present at the body center. What is the formula of the compound? If the solid is made up of P and Q, by using the previous knowledge we have to calculate. It's very simple. First step, you have to calculate number of Q particles. Number of Q particles calculated very simple. We know it is present at the corner, which is equal to corner points into contribution. Corner, Q is dispersed at the corner, so there must be corner points. How many is there? 8. What is the contribution of corner? You know, dear students, it is 1 by 8. So the calculation will be 8 into 1 by 8 and answer will be 1. How many number of Q are there? 1. Number of P, body center point into contribution. How many body center P is there? 1. What is its contribution? 1. So the answer is 1 into 1, which is equal to 1. So number of Q is 1, number of P is 1. You can write either Q1 P1. Since both are of same number, you delete the number and therefore the formula is QP. Isn't it easy? Such kind of numericals will be asked, dear student. So if they want to make this numerical little critically, little difficult, what they do, they just say, continue the statement like, say suppose one of the corner point is missing. One of the corner point is missing means how many corner points left? 7. Calculate its contribution. Like that you have to understand. You know the concept, apply it to solve the numericals. Let us go for the second problem, number 2. Students, a compound formed by elements X and Y crystallizes in the cubic structure FCC, face centered cubic structure, where X is at the corner of the cube and Y is at the face center. What is the formula of the compound? You imagine this structure, dear student. FCC they have mentioned, this is the structure, face centered cubic unit cell. Reading a question is very important. It is made up of two types of constituent particles, that is X and Y. Yes, we know there are two types of lattice points also. One is at the corner and another is at the center of 6 faces, dear students. Okay, in this type of FCC, X is at the corners of the cube. What is the X? X is at the corner of the cube. How many corners? 8, you know. Y is at the each face center. 6 faces, 6 face centers. It's very easy now to calculate the formula. How it is done? Let us calculate number of X. We can do it in one stretch or we can take multiple steps. Number of X is equal to corner points into contribution. How many corner X points are there? 8 is there. What is its contribution? 1 by 8. 8 into 1 by 8 thus is equal to 1. So how many X is there? 1. Now number of Y at the face centers, 6 face center is there, which is equal to face center points into contribution. How many face center points are there? 6 is there. What is their contribution? 1 by 2. Therefore it is 6 into 1 by 2 is 3. How many number of Y is there? 3. How many number of X is there? 1. Therefore the formula is XY3. Students, they can make this numerical bit difficult, bit thinkable, just by adding this statement like, say suppose one of the lattice point at the corner is missing. How could you do this? You can calculate it very easily. Corner points are x, but one of the lattice points is missing, therefore total 8 is there, one of the missing in the sense 7. Calculation would have become 7 into 1 by 8, thus it is 7 by 8. How many number of x in that case? 7 by 8. So such kind of puzzles can be added in solving numericals. Hope you have understood this solving numericals. Okay, thank you. Dear students, let us understand close packed structure. Students, close packed structure, in this discussion we are going to understand the structure of given solid. Students, a solid is made up of constituent particles, and the arrangement of constituent particles, in reality it is in 3 dimensions, that is 3D. The structures of solids are always in 3 dimensions. To understand 3-dimensional structures, we need to understand the solid or the structure in 1 dimension, in 2 dimension, and finally in the 3 dimensions, dear students. Let us understand it in step by step. In solids, the constituent particles are close packed. Understood what is the reason for close packed? Particles are arranged closely because due to strong intermolecular forces, leaving the minimum vacant space. Let us consider the constituent particles as identical hard spheres and build up the 3-dimensional structure in 3 steps. First, close packing in 1 dimension. Suppose if constituent particles considered as hard spheres, if they are arranged in 1 dimension, in this arrangement each sphere is in contact with 2 of its neighbors. How it is arranged? Initially in the slide you have seen each spheres, they are arranged like one after other in a row. The spheres are arranged in a row touching each other. Look at this. These are the spheres. You can understand them as the constituent particles. How they are arranged? To make some explanation, I have made it different color, but all of them are of same type. How they are arranged? They are arranged one after other touching each other. The number of nearest neighbors of a particle is its coordination number. Say suppose this particle which I am pointing, how many neighbors are there? 1 towards the left, 1 towards the right. Each of them is having 2 neighbors. Therefore, neighboring atoms, number of neighboring atoms are called coordination number. So the coordination number is 2. Understand, dear student, you may ask me, you may get the question, sir, what about this corner? They have got only 1 neighbor. No, we have just taken a part of solid. There exist the neighboring atoms for this also. Hope you have understood what is coordination number. This is called close packing in 1 dimension. Look into this. Suppose if I select any one of the constituent particle, and if I look into this, if I understand what is the nearest neighbors, what is the coordination number? Can you tell me what is the coordination number of any particle? I have chosen this. Exactly, you can say it. 1, 2, 3 and 4. What is the coordination number? It is 4, dear student. Understood? Another point you can understand, what structure you can see this, what structure you can, it looks square. Okay, therefore this type of arrangement, what type of arrangement, A and A type of arrangement is called square. Since it looks square, close packing, because the arrangement is close packing, how it is in 2 dimension. I hope you have understood. What is its coordination number? That is 2. See the arrangement. If the first row, if I call it as a B, I may call also it as a A. Okay, the other row, since it is arranged in the depression produced by the first row, it will be called as A. Suppose if this repetition repeats, this arrangement repeats, like AB, AB. Okay, it is also, hence it is also called as AB, AB type of arrangement. Students, I have just made a change in the color just to explain. Otherwise, they are of same type. See, I'll choose this particular constituent particle or sphere. You can see the neighboring spheres. Okay, see 1, 2, 3, 4, 5, 6. It appears like a hexagon and 6 in a number. Therefore, coordination number is 6. Since it appears to be a hexagon, the name can be justified as hexagonal close packing. 2-dimensional hexagonal close packing, AB type. Students, thank you for kind listening. In the next slide, we are going to understand about the 3-dimensional arrangement of constituent particles or spheres. Thank you.